we are now in week 7 on Friday, and we are about to finish lecture 7, the last part of lecture 7, which is on aluminum alloys. Okay, so if you recall back, lecture 7 is all about ferrous and non-ferrous alloys, and I've discussed to you what is carbon steel, what is stainless steel, what is cast iron, and today I'm going to discuss on what is aluminum alloys. So aluminum alloys, can anyone guess where does aluminum alloys falls? Is it ferrous or non-ferrous? Is it in high alloy steel or low alloy steel? Can anyone guess? Can anyone just type it up? Okay, Clement says ferrous. Anyone else? Theo Chanhan says non-ferrous. Okay, who else? The answer states here. Non-ferrous. No problem, Clement. It's okay, no problem. We are learning, all of us are learning. Okay, the answer is non-ferrous actually. Okay, if you look at these guys, okay, the reason why I ask is some students might get confused. Okay, since stainless steel is ferrous, you know, stainless steel is over here. Remember last week we read about stainless steel? Stainless steel is still ferrous, but it is under high alloy category. Can you see? Steel, ferrous. Aluminium is non-ferrous over here. So before this, from my experience before this, lots of students having this confusion. They said aluminum is under high alloy steel because they have this. Even myself, when I was a student, okay, I used to do this kind of mistakes. So it's totally normal, Clement. Okay, it's totally normal. Aluminium is silver, stainless steel is also silver. So when I was a student, I put those in this category, high alloy steel. I was wrong as well. So it's okay, no problem with that. So just what they call that, update this in your knowledge. Aluminium, copper, brass, all under non-ferrous. It means that the iron content is minimum. Okay, ferrous means you have a significant amount of iron content. Stainless steel have significant amount of iron content and significant amount of chromium. That's the reason why they call it high alloy. Okay. Most of the non-ferrous is non-magnetic. Okay, most of the non-ferrous is non-magnetic, but you cannot rule out that non-ferrous is also, ferrous must be magnetic. No, some of them are non-magnetic as well. Okay, Lua Wenzeng. Okay, Lua Wenzeng. Okay, all right. So let's talk about aluminum alloy, guys. So I've discussed you steel and cast irons, and then let's go to non-ferrous. So there's one example for non-ferrous aluminum alloy. So aluminum alloy, the characteristic of aluminum alloy, it has a very low density, 2.7 gram per centimeter cube, and it is very high electrical and thermal conductivities. You need to highlight these. Same goes to copper. Very high electrical and thermal conductivities, aluminum and copper. Okay, very high electrical and thermal conductivities. And aluminum alloy has a good resistance to corrosion in some common environment. Okay, because the presence of iron is very less, so it has a good resistance to corrosion, but it has some drawbacks. When you cold work aluminum, the resistivity to corrosion deteriorates. Okay, the resistivity to corrosion deteriorates. So aluminum can be cold worked, but if you cold work, you increase the strength because aluminum is very ductile. You know, aluminum, you can bend aluminum, right? If you're a strong person, you can bend aluminum easily. It's very ductile, but you can increase their strength by cold working the aluminum. Okay, but if you cold work aluminum, you are reducing the corrosion resistivity. Okay, take note of these. And aluminum alloy are easily formed by virtue of high ductility. Okay, it is very high ductility. Here, cold work is it is cold workable and alloying enhance the mechanical strength of aluminium but tend to diminish resistance to corrosion. Okay, you can also add alloying agent, but it diminishes the resistance to corrosion. Aluminium has a very low melting temperature. It's about 660 degrees Celsius. So if you have a homemade furnace, if you have a clay, red brick clay, and you keep on heating the clay for about 600 degrees, 650 degrees Celsius, when you put a chunk of aluminum, you can melt it. You can melt aluminum in your, in your backyard if you have a homemade furnace, right? And since it has a very low melting temperature, aluminum restricts the maximum temperature at which it can be used. So not all application you can use aluminum. So most of the aluminum you can find is in your phone casing, pen covers, any material that needs to have a metallic finishing touch but doesn't require high strength or doesn't operate in high temperature. Okay, so aluminum can be classified into two types. One is cast aluminum, we call that as cast aluminum. Another one is wrought aluminum. Okay, so when I say cast aluminum, it means that it is being casted. You have sand casting, you have investment casting, you have lots of type of casting. It is being casted into complex shapes. When I say wrought aluminum, it means that it is being cold work. So it means it is cold work, wrought aluminum. Okay, let's look at wrought aluminum. Wrought aluminum, which are initially cast as ingots or billet. Okay, initially it is cast aluminum, but subsequently hot or cold work mechanically to desired form. Okay, it has been worked. It can be either cold or hot. Okay, we have hot working and we have also cold working. All right, so example of hot working and cold workings: rolling, extrusion, forming, and forging. Okay, you have forging, you have forming, you have extrusion, and you have rolling. And these two metal processing techniques, rolling, extrusion, forming, forging, I will be discussing this extensively in coming days. Okay, we have a lecture for this. Rolling. So rolling used to produce sheet, foil, or plate. Extrusion to produce profile tubes or rods. Okay. Forming to produce more complex shapes from rolled or extruded stocks. And forging is to produce complex shapes with superior mechanical properties. Okay, don't worry guys, I'll be discussing with you what is forging, forming, extrusion, and rolling in coming days. Very interesting to watch this, and I'll also share you some videos in YouTube we can watch together. Nice to see on all those manufacturing process. Okay, so that is wrought alloys. Wrought aluminum alloys. Now cast aluminum alloys. So cast aluminum alloys are directly casted into their final form by one of various methods such as sand casting or die pressure or die casting. Okay, we have die cast, sand cast, investment cast, and so on. Okay, casting is used for complex product shapes. So aluminum can come up with a very complex shape. Same goes to cast iron, can come up with very complex shapes. Remember cast iron over here? Cast irons. Okay, so one of the easiest things that you have as a cast iron is your engine block. Okay, your engine, your car engine block is made of cast irons. Complex shape, you can come up with a very complex shape. This alloy contains high level of silicon. Okay, so why they use high level of silicon is to improve their castability and flowability or fluidity here. Okay, so casting aluminum alloys contains high level of silicon, 5 to 12%. This is to improve their casting strength, okay, fluidity, flowability. Now let's look into classification of aluminum. Let's look into classification of aluminum. Composition of cast or rod types is designated by 4-digit numbers that indicates the principal impurity and the purity level. For example, pure aluminum, which is 99% minimum or greater, this is the classification 1. When you have a majority of copper in the aluminum, we call that 2, starts with 2. Manganese, 3. Silicon, 4. And so on, 5, 6, 7, 8, 9. So for route alloy classification, according to the major alloying element, all made of 4 digits. The first digit is the major group of alloying element. For example, pure aluminum always 1. If your major alloying element is copper, it starts with 2. Second digit is impurity limits. What are the limits of the impurities? Second last two digits is identify aluminum alloy. What kind of aluminum alloy is that? Okay. For cast iron, exactly same, but you have decimal points on the end. Okay, decimal points at the end. For cast alloy, a decimal point is located between the last two digits. Composition of casting alloy, what they call that, the classification is exactly the same, just that you have point form in the end, decimal points. And also some alloys, you have temper design. The temper means, do this aluminum goes to heat treatment or not? For example, 20246. Okay, so you have T, you have A, you have here O, H, T, H, and so on. So temper design designed designed by Hypen. All right. The temper designation is a better and possibly a 1 to 3 digit number, okay, which indicates the mechanical or heat treatment to which an alloy have been subjected. For example, F means as fabricated, okay, cast or wrought alloy. O means annulled, okay. H means strain hardened. Strain hardened means cold work. T means heat treated to produce a stable temper. It's okay, 2xxx dash T. So you have T1, T3, T4, T5, T6. And so strain hardened alloy, strain hardened and partially annealed, strain hardened and annealed. Okay. No exams will be open book. You can always refer to this if you wanted to refer. Okay. But not important, I would say. Okay. And then these are the applications of aluminum alloy. Okay. The ductility is here. You can view that this is pure alloy, yeah, 1100. Pure aluminum. Okay, 1100 is here. 1100, number 1. Pure aluminum. You can see the ductility is very high. As you add more alloys, the ductility reduces. The tensile strength increases. See? Because this is heat treated alloys, wrought alloys. Wrought alloys, and then you have cast alloys. And then you have lithium aluminum alloys. Okay, and these are the applications that you can have a look, and you can look as a reference for you. Okay, guys. So just and this non-technical, all are read-ups and also educated knowledge for you. Okay, guys, any question? Any questions? Yes, in the exam, you need to use all these tables. Yes, you need to use all these tables. Now, okay, since you have asking about exam and test question, okay, do you have any questions regarding to topic 7? Because I'm going to discuss on this matter in a while. Do you have any questions on topic 7? Lua Wenzeng, hold on for your question. Huh? I'll come back to you on this. Other students, do you have any questions on topic 7? Guys, any questions? Topic 7? So, no questions. Okay, let me know if you have question, if you have anything in the chat box. Okay, guys. Okay, now let's talk about exam and test. So your test will be commenced on next week, Tuesday. Okay, next week Tuesday, and the duration will be 2 hours. Okay, the duration will be 2 hours. I will log into Webble. Oh, hold on, guys. Okay. So your test is next week Tuesday. Tuesday 2 p.m. till 4 p.m. Okay, there will be 2 questions. All right, and I've designed the test so that you should be able to answer the question in half an hour. 1 question, half an hour. 2 question, 1 hour. And then I'll give you 1 hour for you to submit your test in Webble. Okay. All right. So during your test, guys, during your test, I'll be giving you the question paper in Webble. Okay, I'll open a question paper in Webble, and also I will upload the answer script. So the answer script is very same as the answer script that you will about to get in your final assessment. So this is to make sure that you are familiarizing yourself with the final assessment. So what I'll do is I will release the answer script earlier. Okay, let's say your test is at 2 o'clock. I'll release the answer script around 1:30 to 1:45, around that time. So you can download the answer script. You can fill in all the details in the answer script and ready for the test. Okay. And then when you're doing your test, guys, when you're doing your test, you open up topic 1, 2, 3, 4, and 5 readily in PDF. Okay. So test 1 will be covered until topic 1, topic 2, topic 3, topic 4, topic 5, and topic 6. Okay, up to topic 6. All right. So you open up topic 1, 2, 3, 4, 5, and 6. Open those folders and just put aside and wait until 2 o'clock. So once you receive the question, you may refer to any means of what they call that materials, but please don't copy with your friends. Okay, I'm repeating this. Please don't copy with your friends because it is very easy for me to detect plagiarism between two documents. Okay. And also, when you are answering the question, when the question is subjective, you need to type it out in Word document. Okay. No, topic 6, until topic 6. Heat treatment. Topic 5 and topic 6 are both familiar, very familiar. Okay. All right. All right. Iron carbon phase diagram is given in the question paper. Okay. Luar Benzeng, don't shiver. Okay, iron carbon phase diagram is given in the question paper because, as I told you, iron carbon phase diagram are very complex, right? So I've attached those in the question paper itself, so it's very easy for you to refer. Okay, got it? Understand, huh? Okay, good. So whenever there is a question, subjective question, you need to type it out in Word document. When the question asks you to, for example, phase diagram, there's a lot of formulations, right? What do? You take a piece of paper, A4 paper. So make sure you ready all these papers beside you. Okay. So this is for time saving. Okay. Take a piece of paper, write down the answer, and then you need to take a photo. And as we discussed last time, some people have few ideas on that. Take a photo and you need to attach those in Word document. Okay, once you attach in Word document, you can come up with a caption saying that this answer is for this question, blah, blah, blah. That's all. And let's say if the question asks you to draw something, draw something, you need to sketch or draw something. You may also use a piece of paper to draw, take a photo and attach it in Word document. Okay. So the most important thing in test and also final assessment is time management. Okay, time management is very important. So I'll open the question at 2 p.m. and I will close the submission, what they call that submission link sharp 4 p.m. So the test duration is 2 hours. Okay. You may set time, Clement, wait, you may set time for you to answer question number 1 in 30 minutes. Question number 2 in another 30 minutes. So 1 hour is gone. So the next 1 hour is for you to, the next 1 hour is ample of time, okay, for you to do whatever formatting or whatever copy paste things in it and then submit. Okay, so in final assessment as well, 3 hours. So I'm giving you question in, I've designed the question for you to do it within half an hour. One question, half an hour. Each question, half an hour. So in final assessment, there will be 4 questions. 4 questions, half an hour each. So you can manage to set your time to do it within 2 hours. Okay, half an hour, half an hour, half an hour, half an hour, and then 1 hour for you to do the submission. Okay, so your final exam is on 8th October. It's not physical assessment in, no, it's not physical exam. It's all virtual here in Rebel. Okay. All right, guys. So this is how it works. Before exam, make sure you take a piece, you have ample piece of paper beside your desk and your phone is fully charged. And then I will release the answer script earlier, half an hour or 15 minutes earlier. So you may fill all the forms and familiarize yourself. Then I'll release the paper. You can start doing it, write it, set the time, half an hour, and you may refer to notes. Okay, you may refer to notes. So prior to exam, please open and set the timer half an hour for each question. Okay, set the timer half an hour for each question, then you can have a very good time management on it. If you are unable to answer them, and just go to the next Word document and start typing. It's okay. Then you can refer it when you have time. Okay. Don't mingle. I mean, same like your final exam as previously, okay. Just that this time is you are doing it in computer. Before this, it was all your writing. Here now you're doing it in computer. So exactly the same thing as what you did last time. Your final assessment in Utah, final exam in Utah. Hold on, guys. Hold on a minute. Sorry, I got a phone call. So exactly same as your final exam previously, just that you're doing it in computer. So the timing is important, and also set the question, set your time, your mental time. You only need to spend half an hour for each question. If you manage to answer the question within 50 to 20 minutes, some question, yes, you can manage, you can answer it very easily. So you are saving more time on that. Okay, so take test one. So test one looks very familiar to your final assessment. Okay, take test one as your final assessment as well. It looks very familiar, exactly the same thing, just that final assessment you have 4 questions, for you have 2 questions. That's all. All right. Okay, guys, understood? Understand? Okay, don't shiver, don't shiver. I want you to have this face during holiday. Okay. And also I'm going to give you some tips. Please look into face diagram. This is my tips. Okay, so now all of you are happy. So please look into face diagram. For face diagram, it is not necessary for you to print out. Okay, you can just use. Okay. No. One of the question is face diagram. So I'm giving you a huge tips on that. One of the question is related to face diagram. To be specific, iron carbon phase diagram. Okay, so just master on that. And also there are clusters, because question 1 you have A, B, C and so on. So there are some clusters or chips of other topics as well. Okay, for example, guys, this is your phase diagram. Okay, this is your phase diagram. So if you want to draw, you can just go to insert and then just go to shapes and just draw a line. Finish, done. Okay, and then you can go to another line. If you want to copy paste this, copy and then paste it here, another one. That's all. It is not necessary for you to print it out. Okay, you want to go for another line, I'll draw this one line here, done. That's all, finish. Done. Lower Wenzeng. Essentially, this is phase diagram, all right? This is what you're going to use your ruler and line. So instead of using ruler, you're using mouse and keyboard. That's all. So R and S, blah, 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 and done. So I've done it within a minute. Done. Finish. Okay, so this is your composition. This is R, this is S. Find the values, blah, 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 finish. The calculation, I'm repeating this, Lua. The calculation you can write in a piece of A4 paper. Don't write in Word document, okay? I don't expect you, guys, please don't do this, please don't do this, okay? Because I don't want to see this, okay? Where is it? I also find it difficult, okay? You go to this equation and then you come up with this kind of calculation, you type it one by one. No, 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 don't do this, okay? You'll be having a very bad days. This, no, okay? I don't want this calculation, all right? Whatever numbering or drawings or calculation involved, write down in a piece. And then remember, I told you, put 1/2 table and you bring up the this Batman guy, the figures. So figure one, question one, something like that. Okay, that's all. So the reason why you create this table is so that table actually makes things easier for you to make sure it is perfectly fit in the what they call boundary area. Okay. All right, guys. Clement can prepare and type it one day before test, then copy paste. No, 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 no. Oh, what do you want to prepare, Clement? I don't understand. Which one you want to prepare? I don't understand your question, Clement. Equation in words. No, 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 no. Don't prepare. You don't know what kind of question is going to come out. Okay. Just take a piece of paper and just the one that going to take time is you take a photo and then you are going to sync it in the computer, right? So that for that case, I can't help you. You need to practice this yourself. Okay, you can practice this anytime. Okay, today or tomorrow. Just take a photo. Make sure when you're taking a photo, guys, make sure it is horizontal, perfectly vertical, 90 degrees, right angle. Take a photo, snap photo, and send. So you can practice that anytime you want. For that, I can't help you because it solely depends on you. For all these, the tips that I have in the back of my mind, I can teach you lah. Okay, figure one, how do you going to write these? Don't write all these calculation. For these, you can just draw a line. If you don't want this line, just delete these and so on. Easier. Okay. So you want to make it thicker, go for format. Okay. I like the equation toolbox. Use it always. If I wanted to use, can. If you want to use the equation toolbox, if you think that it is easier for you to do that, can. But most of the students they find it difficult. Even myself, I really don't like the equation toolbox. So if you feel you want to use equation toolbox, go ahead. No problem with that. As long as you give me the correct answer. Okay, Teo Chan Zan. Just afraid my phone camera quality is not good. Clement, I don't know how to help you on this. All right, guys. Try your best. Try to get well, and also make sure no one in your house disturb you at that time, lah. Okay, suddenly there's a kid coming here and asking you for a toys, or your mother asks you to go to grocery shop to buy bread or vegetables. Don't do that, lah. Okay. So set your time, and make sure you focus. The key here is one question, 30 minutes. Set the timer. Because you have all the luxury. When you are attending exam in Utah Hall, you need to put your, what they call that, phones, you need to put your pencil case all down, right? Essentially you're stripped off. For this, you can do whatever you want. Okay, you can set your phone, you can set your timer, you can take a thick reference book, blah blah blah, anything. Okay, just that it is, I'm testing on the time management of yours. The questions are easy. Okay, I'm testing on the time management. Okay, so any questions, guys? Any questions? Any questions? Yes, we have tutorial today, and oh yeah, sir, we have to submit the files. Yes, you need to submit your exam file, both Webble and email, right? No, no, no. You just submit it through Webble. If you can't submit it through Webble, you can email me. That's all. I'll open a link in Webble. You just need to submit in Word document. Okay. Don't email me and also Webble. No, I don't stress yourself. You know, not necessary for you to submit through Webble and email. Just Webble is doable. If you can't submit through Webble, you can email me. And also at that time, I will be in Microsoft Teams. If you have any question, you can dial in, or you want to chat, you can chat. Okay. Everything is in Word format, not PDF. Only in Word format. Okay. Yo Zin 1, the lines insert in, okay, the lines on the diagram may run away. Where is it going to run? This is it. This is it. Can I just over here, guys, look at this. Okay, here you need to adjust this. Phase diagram. No, you just need to go and fix it. Okay, make sure you just fix it lah. Right click and group it. Like this, it won't run. See? When I group this line, it groups. Guys, I think I need to teach you this as well. Okay, see, yeah. Okay, but all these are just skills lah. Okay, all these are just skills. Look, look, everyone look. It won't run, it won't run. Okay, so I'm going to write this. Okay, and then I'm going to insert another line. So now I'm schooling you, and I'm going to insert another line. Okay, let's say this is your midline. Done. And then insert another line here. This is your tie rod. Okay, done, right? So you are scared of this, right? Oh, run away already. Okay, what do you do? You click this line, click control, press control, click on this line. So you have selected line 1, this image and this line. Don't release the control button. Click on this line, click on this line, and also click on this line. Sorry, click on this line. Okay. Okay, then right click. So you have selected all the lines, right? Right click, group, and you group all these into one. So all these are now one group. So can you see this? Okay, can you see this, guys? I've grouped these except for this line. I haven't clicked these, I guess. Can you see? It is moving along the line. So if you haven't grouped this line means you can always group it as well. Okay, now it's easy. Okay, so I need to group these and also these as well. So right click, I'm grouping these as well. So the whole thing is being grouped. Can you see, guys? So I'm moving these, Okay, guys, learn, huh? Okay. So practice on this, how to group lines, how to group images together. This show the possibility to miss some lines. Yeah, of course. All right, but you can just select, just you move the line, but not necessary for you to move the line all together, So just disgroup it. Okay. Okay, guys. Shift window as, yeah, some I don't know about this Teo Chan Zan. Shift plus window S is also quite useful. Okay, I have no idea on that. So try to master these, guys. Try to make sure you have all the soft skills before the test. Just remember the objective is to finish the question within half an hour. Each question half an hour. That is your time limit. And of course, you need to study all. You need to study lecture 1. Okay, this is your engineering knowledge. This is the reason why you're coming for the class. Okay, make sure you understand what is engineering materials is all about. Okay, that is the most important thing. Okay, guys, we're running out of time. Okay, remember in tutorial 1, I've mentioned to you that question number 8 and number 9 I'll discuss to you later because we haven't covered this. Remember, we have covered question 1, 2, 3, 4, 5, 6, 7, but question number 8 we didn't continue. So I'm going to teach you that, but once I've seen it, guys, question number 8 and number 9, calculate the number of aluminum atoms and also theoretical densities on BCC, FCC, HFC, and so on. This is not being covered closely in this course. Okay, question number 8 and number 9 is more on material science subject. Okay, but anyway, since this is in the tutorial, but it is not being taught in the lecture. Okay, this is more on the what they call that material science course. But you have a trace of FCC and BCC in phase diagram. Okay, FCC and BCC in phase diagram, but nothing, there is no questions or there is no lecture on teaching you on how to calculate the number of aluminum atoms or the lattice parameters or the density of BCC and so on. So this question number 8 and number 9 is just a questions for your knowledge. That's all. So it won't be covered in your test because there is no lecture on this. Okay, but anyway, since it is in the tutorial 1, I'm going to give you the answer for these questions. Okay. All right, guys. So for question number 8, guys, I want to cover this in lecture class. So for question number 8, calculate the number of aluminum atoms per centimeter cube given the lattice parameter for FCC is, hold on, lattice parameter for FCC is 0.405 nanometer. Okay, so for FCC, there are how many atoms per unit cell? Okay, if you Google it out for FCC, okay, these are under material science. Okay, if you look at FCC atom, okay, FCC atom, if you look at this, FCC has 4 atoms in a unit cell. Okay, since FCC has 4 unit atoms in a unit cell, FCC has 4 unit atoms in a unit cell, the question asks you to find the number of aluminum atoms per, and the lattice parameters is 0.404 nanometers, the distance, the lattice parameter. So what you need to do is 4 divided by 0.404 nanometer, and the nanometer you change into centimeter. Okay, if you look at the answer, this here. No, this is tutorial 3. Here guys, question number 8. There are 4 atoms per unit cell. There you go, 4 atoms. And then you divide it by the lattice parameter, which is 4.05 10 to the power of -8 nanometer changed to centimeter. And then you can find the aluminum atoms per centimeter cube. Remember, FCC has 4 atoms only per cell. But the question asks you how many atoms in per centimeter cube. But they have given you for each atom, the distance, the lattice parameter is 0.405. So 4 divided by 4.05 10 to the power of -8. So these are the number of atoms you have in per centimeter cube. 6 times 10 to the power of 22. So such a huge amount of atom in 1 centimeter cube of volume. So that, imagine guys, these are the, imagine how small the atoms are. Okay. Now let's look at another question. Next question. Calculate the theoretical density of BCC ion. So for, if you look at BCC, BCC has how many atoms? BCC, body cubic centered, has 2 atoms. FCC is 4, BCC is 2. Calculate the theoretical density of BCC ion, given that the lattice parameter of ion is, okay, 2 times 2.866 times 10 to the power of -8 centimeter, and they have given you the atomic weight as well. So you need to find density. Okay, density is mass per volume. Okay, so mass per volume, you need to find what is the mass. So you have 2 atoms in a cell, and each weighs 55.847. So 2 times 55.847 divided by the volume. And also this is the lattice parameter, this is the distance, but you need to find the volume. So you need to find times with the number of atoms in 1 mole. Okay, since this is mole. So if you look at the answer over here. So if you look at the answer, density is mass per volume. So mass you times, in BCC you have 2 ions in each unit cell, and the density for each unit cell is 55.84. So sorry, the density for ion. Density for ion is 55.847 gram per mole. So 55.847 gram per mole divided by the, you need to find the volume. But since they have given you the lattice parameter, which is 2.866 times 10 to the power of -8 nanometer changed to centimeter, you need to times with total number of atoms in 1 mole, which is Avogadro's number, 6.022 times 10 to the power of 23. Okay, so you got as 7.879 gram per centimeter cube. Okay, so question number 8 and 9 is not being covered in this subject. Don't worry, I won't be asking calculation on this subject. Just you need to know what is BCC and FCC, because austenite and perlite, okay, you remember? Okay, what is BCC and what is FCC in? Ferrite is BCC, austenite is FCC. Remember, that is good enough. Okay, there won't be calculation enough. There won't be calculation asking you what is the density or the aluminum atoms in a lattice parameter. Okay. Okay, guys. So that's about it. Any questions? Luo Wenzeng, are you okay? Okay, good. So I'll be having tutorial in a while, 11:30. So do you have any questions, guys? Do you have any questions? Because next week we're going to start our test. No, next week, Tuesday, our meeting is going to be test. So do you have any questions now you'd like to ask? So I will be in Microsoft Teams at 1:30 next week, Tuesday. So you can come over and then please on your Webble and make sure you just stand by on that time. So I'll be creating the of course I'll having a meeting here, so you can log in here and just wait for my thing and then you can start doing it. Okay. Okay, any questions, guys? Please make sure you sign your attendance. Please make sure you've signed your attendance.